Hi Smarties, welcome back. Hi Smarties, welcome back. So today we'll be doing a question on Euclidean geometry. So let's read the statement, right? From a point A outside the circle, this is our point A, center O, two tangents AD and AV. So our tangent is AD and AV, right? Are drawn. AO and VD intersect at M. So BOD is the diameter of the circle, meaning that the angle BVD is 90 degrees because it's an angle in a semicircle, right? So they say that BV and VO are drawn. V angle AD is 40 degrees. So this one is already given. And they say that prove that quadrilateral VODA is cyclic. So we say that to prove that something is a cyclic quadrilateral, right? We need to see angles from the same segment, or it's either when we sum the opposite angles, they are supplementary, or we also say that it's either we have an exterior angle of a cyclic quad. So that's when it can be cyclic, right? So now we need to check our VODA. For it to be cyclic, it's either we get those three things that I said. So now let's focus on VODA. So we are told that DA, AD, and AV are the tangents, but when we see we have the radius that intersects the tangent. So we know that this is a 90 degree and this is a 90 degree, right? So it means that when we're going to explain, we're going to say that our AVO, right? A angle VO must be equal to 90 degrees. What is the reason? Is that the tangent is perpendicular to the radii. So tangent perpendicular to the radius. And the other one, O angle DA must be equal to 90 degrees because the tangent is perpendicular to the radius, right? So therefore we say that A angle VO must be equal to O angle DA. So we remember if this is 90 degree and this is 90 degree, when we sum them up, they're going to give us 180. So we can then conclude that therefore VODA is a cyclic quad, right? A reason is that is the converse of opposite angles of a cyclic quad are supplementary. So, converse of opposite angles of a cyclic quad are supplementary, right? So now we're going to move on to the next question, which says calculate the magnitude of angle O1. So this is our O1, but we need to mind something. So since we already proven that this is a cyclic quad, then we can use it to answer the following questions, right? So please can I draw a bit of a circle to show that this is now a circle, because we've already proven that it is a cycle indeed. Have a cycle. I'm so sorry for the shade, but I'm doing it so that we can be able to answer the questions. So this is our angle O1. So our O1, since Voda is a cyclic quad, we can see that this angle here is equal to the internal opposite angle. So meaning that angle O1 must be equal to 40 degrees. What is our reason? It's an exterior angle of a cyclic quad equal to the interior opposite angle, right? So I just hope it's clear. So now we're going to prove that BV is parallel to OA. So they're saying that we must prove that our BV is parallel to our OA. So what is going to happen here? It's either we are proving that this angle here at B is equal to the angle here at O3, which is going to be our corresponding angles because we have an F. If this is parallel to this, right, we have our F here. So it's either this angle is equal to this angle, or we prove that the angle at B plus angle O1 and O2 is 180 degrees because these are the core interior angles and we know that they are supplementary, right? And another thing, we have an N, so it's like this. It's either we prove that our V1 is equal to our angle O2. So we need to prove that, right? So now we're going to check. We want to know what our V1 is. So what we are seeing here is that our V1 is equals to the angle at B. Why? Because these are angle opposite equal sides, because these ones, they are from the same radii and the radius here are equal. So this is equal to this, meaning that this is equal to this because they are the base angles of an isosceles. So we're going to say that angle V1 must be equal to angle B, right? Reason, angles opposite equal sides. And we know that our OB is equals to our OV. So OB must be equal to OV because they are the radii, right? So this is it. So now we can calculate our V1 since we know what our O1 is. So we say this is 40 degrees, right? And then we're going to say that angle O1 plus, and then we know that we have V1, angle V1 plus, we know that angle B is equals to V1. So we can just say angle V1 is equal to 180 degrees. What is our reason? This is sum of angles in triangle bani OBV. So you need to mention the triangle that you're working on. It's OBV. So we say that 40 degrees plus 2 angle V1 must be equal to 180 degrees. So 2 angle V1 equal to 180 degrees minus 40 degrees, and then we divide it by 2. So we know that therefore our angle V1 must be 70 degrees, right? So another thing, since we know that this is a 70 degree, we have to prove that also our O2 is what? It's 70 degrees. So how do we go about it, right? We know that we have the tangents from the same point, meaning that our ADM is the same as AVM, right? So we're going to say that A angle DM must be equal to A angle VM. What is our reason? Is that these tangents, they are drawn from the same point A, so it's tangents drawn, okay, still visible, from a common point, then you mention the point which is A, right? You close. So now you're going to get the magnitude of ADM, right? So A angle DM plus A angle VM plus angle A, all of angle A, right? Angle A must be equal to 180 degrees. What is your reason? Sum of angles in triangle AVD, right? So why are we saying this is AVM? So we're going to change this to ADM because we've proven that ADM is the same as A angle VM. So we say that A angle DM plus A angle DM, plus what's our angle A? It's 40 degrees. This was already given. Plus 40 degrees must be equal to 180 degrees. I'm so sorry about this. This was our reason, right? So we say that 2A angle DM must then be equal to 180 degrees minus 40 degrees because we're going to transpose the positive 40 to that other side, then we divide it by 2. So we know that therefore our A angle DM must be equal to 70 degrees. But then there's something that we need to remember, right? We said that we have a cyclic quad, so we need to remember that we have a cyclic quad. So this angle here is equal to this angle here. Angle ADM is the same as angle O2. Why? Because we say that these are the angles from the same segment, since this is a cyclic quad, right? So we're going to say that A angle DM must be equal to angle O2, which is equal to 70 degrees, right? So these are angles subtended by the same chord, right? And then we're going to check the chord that subtends ADV and angle O2, which is AV. Chord, so angle subtended by the same chord, the same chord AV, and then we close. So we need to remember that in order for us to prove that these two lines are parallel, it's either we prove that angle V1 is equal to angle O2. So remember that our angle V1, we calculated it and we knew that it's equal to 70 degrees. So we're going to say that therefore angle V1 must be equal to angle O2. So what do you see here? That this angle here is now equal to the angle O2, right? So these are alternative angles. So we're going to say and conclude that therefore BV is parallel to OA. What is our reason? It's converse of alternative angles, right? So I hope it's clear. Thank you.